Electromagnetism is one of the four fundamental forces in nature. I've already made videos on the other three, gravity, the strong force and the weak force, if you'd like to check these out. Electromagnetism is the second strongest of this quartet after the strong force. Two features of it make it unique. It's the only force that acts between electric charges, and it's the only force that can be both attractive and repulsive. Electromagnetism is the dominant force in interactions between atoms and molecules. It binds negatively charged electrons to positively charged atomic nuclei, ensuring that stable atoms can be formed and that chemistry, including the chemistry of life, can happen. For as long as we've been human, we've been aware of phenomena that are electromagnetic in nature. Lightning, for instance, and the attraction between magnetized pieces of iron ore. But it wasn't until the late 18th century that scientists began to develop a mathematical basis for understanding the nature of electromagnetic interactions. In the 18th and 19th centuries, prominent scientists and mathematicians such as Charles Coulomb, Carl Gauss and Michael Faraday developed laws subsequently named after them which helped explain the formation and interaction of electromagnetic fields. This work culminated in the 1860s with the discovery by James Clerk Maxwell of four equations now known as Maxwell's equations, which provide a complete description of classical electromagnetic fields. Electricity and magnetism, these equations show, are in fact just two aspects of a single phenomenon. Moving electric currents caused magnetic fields, and magnetic fields induce electric currents to flow. Maxwell's equations give a sound mathematical basis for the relationships between electricity and magnetism that scientists had been exploring for centuries. But more than that, they predicted the existence of electromagnetic waves, electric and magnetic fields that always propagate at the same constant speed. One form of these, Maxwell postulated, were waves of visible light. Later it became clear that radio waves, microwaves, infrared, ultraviolet, X-rays and gamma rays are forms of electromagnetic waves. They all lie on the electromagnetic spectrum, and the only difference between them is their wavelength. All of them travel at the same constant speed through a vacuum, the speed of light, 300,000 kilometers per second or 186,282 miles per second. Electromagnetic forces occur between any two charged particles, causing an attraction between particles with opposite charges and a repulsion between particles with the same charge, while magnetism is an interaction that occurs exclusively between charged particles in relative motion. These two effects combine to create electromagnetic fields in the vicinity of charged particles. In the 20th century, scientists continued to refine the theory of electromagnetism to take into account the effects of quantum mechanics and Einstein's special theory of relativity. In a subject called quantum electrodynamics, or QED, Maxwell's equations are modified so as to be consistent with the quantized nature of matter. In QED, the electromagnetic field is expressed in terms of discrete particles known as photons, which are the physical quanta or energy packets of light. Another development has been electroweak theory, in which at very high energies such as those prevailing at the time of the Big Bang, electromagnetism and the weak force are unified into a single electroweak force. Even today there are many problems in electromagnetism that still need to be resolved. One of these, for example, is whether isolated magnetic poles or monopoles can exist in the same way as separate electric charges.